All right, we got a good start on 1.4 yesterday with part 1. Today we're going to do section 1.4 part 2. Definitely going to have some of the harder stuff, or probably the hardest problems we've done so far this year. It's our last video on chapter 1. Tomorrow we'll be moving on to chapter 2. Here's a review problem for you. Probably if you started out the first couple days of section 1 or section 1.1, 1.2 doing it without pencil and paper, you might have been able to get the answers right. I think at this point you're probably going to need to write stuff down today. So if you don't have a notebook near you and a pencil, go grab one and work these out on paper. It's going to be a lot easier that way. So that inside number has to be either 4 or -4. So I've got it set up there on the green line. Either 2x plus 8 is equal to 4 or 2x plus 8 is equal to -4. Then I can go ahead and solve out each one of those equations individually. So if I take a look at working out that first one, I have 2x plus 8 equals 4. So I can undo my add 8 by subtracting 8 from both sides, and I get 2x equals -4. Then divide through by 2, and I get x equals -2 on that first piece. If we go ahead and work out the second piece, it's going to be the same steps, subtracting 8 and then dividing by 2. So if I start by subtracting the 8, I'm going to be left with 2x equals -12, because 4 negatives and 8 more negatives on that right-hand side here. 4 negatives and 8 more negatives is going to make -12. Then I can divide through by my 2, and I'm left with x equals -6. Again, these problems yesterday all had two answers because there's two different values in the original problem. 4 and -4, both of those absolute values make 4. Let's go ahead and continue on to some new stuff for today. All right, let's start with example 1. So 3 times the absolute value of x minus 7 plus 9 equals 15. So this problem is going to be similar to one we did yesterday, because we had one yesterday where the absolute value bars weren't by themselves when we started. In this one, we have a 3 and a 9 here on the left-hand side of the equation, which is where x is located, that we're going to have to move before we can get those absolute value bars by themselves. Once the absolute value bars are by themselves, we can split it into two mini equations. In this case, I have an add 9, and that 3 is actually stuck by an invisible multiplication dot. So I'm going to start by undoing my add 9 from both sides by subtracting 9. When I do that, I'm going to get 6 on the right-hand side and 3 times absolute value of x minus 7 on the left-hand side. Then I can divide through by 3. And again, I'm always going to undo my PEMDAS backwards, so I can undo my add 9 before I undo multiplication, since addition is lower in PEMDAS than multiplication. When I divide through by 3, I'm left with 2 on the right-hand side and absolute value of x minus 7 on the left-hand side. Go ahead and work that one out now. Absolute value of x minus 7 equals 2. So again, here I got two answers, 9 and 5. In both cases, I'm undoing my subtract 7 by adding 7, and 2 plus 7 makes 9 on the left. And then in this second one over here on the right, -2 plus 7 is going to make 5. That means those are the two numbers that if I plug them into my original equation here up at the top, that left-hand side will work out to be 15. All right, go ahead and try this one on your own. It's very similar to our example 1. It should be a good practice problem based on that one. So go ahead and try it, and we'll check your answer in a second. So as I'm looking at this one, I have two numbers on the left-hand side that are outside the absolute value that need to be moved before I can split it into two equations. I'm going to start by moving the subtract 3, because subtract 3 is lower than a multiply by -2 in my tree of PEMDAS. So I'm going to undo subtract 3 by adding 3 to the other side, and I'm left with -2 times the absolute value of x plus 5 is equal to -8. Once I undo my subtract 3, I can undo my multiply 2 by dividing by a -2 to both sides. And -8 divided by -2 is a +4. So I have absolute value of x plus 5 is equal to +4. Again, as we were looking at this, I need my absolute value to be equal to a positive. Yesterday we learned if it was equal to a negative, then I would have no solution. So once I divide through by a negative, it is going to become equal to a positive 4. So I can split it into two parts. The first being x plus 5 equals 4, and the second being x plus 5 equals negative 4. So I can undo my add 5 by subtracting 5, and I get x equals a negative 1. And then when I subtract 5 on my second equation, negative 4 subtract 5 is going to make negative 9. Hopefully you got that one. Again, I think if you're working these out in your notebook or on a sheet of paper, it's going to be a lot easier for you to learn and kind of get these right and understand the process versus trying to work it out in your head or using your finger in the air. So hopefully you're writing all this stuff down in a notebook or on a sheet of paper to keep yourself organized. All right, our second example is going to be the absolute value of 2x plus 12 equals 4x. And if you notice in this problem, there's an x on both sides of the equal sign. And when that's the case, we're going to have to check for something called extraneous solutions. And I'm going to do that at the end of the problem. So make sure if you have any of your homework problems that have x's on both sides with an absolute value like this, that you're ready to check for extraneous solutions. Now, for the most part, this problem is actually all set up and ready to go. I know this inside part is either going to be equal to 4x or the opposite, negative 4x, right? So if I go ahead and split this up from the start, I know that that green line is either going to be equal to 4x or negative 4x. Then once I'm there, I can go ahead and solve each of those equations. I'm going to move my x's onto the right-hand side of the equal sign. So this one over here, 2x plus 12 equals 4x. Go ahead and solve that equation. So hopefully you subtracted that 2x over to the right-hand side. Get 12 equals 2x. And then I can divide by 2 and get x equals 6. If I do a similar process on this second equation, I'm going to subtract my 2x over to the right, and I get 12 on the left-hand side and negative 6x on the right-hand side. Then when I go to divide through by negative 6, I'm going to be left with 12 divided by negative 6 is negative 2 equals x. Again, I'm always going to move my x's onto one side and the numbers onto the other side and then divide by that number in front of x. So I got two answers, 6 and negative 2, but I need to check to see whether they work as solutions. And what's going to happen is when you have x's on both sides of the equal sign, you're going to have to sometimes get a no solution, because if this side is a negative, we learned yesterday that we'd have no solution. Since I don't know what x is, that could cause trouble. So I should notice kind of right away that negative 2 is going to cause problems, because in my original answer, if that number is negative, then I'm going to have no solution like I learned yesterday. If I go ahead and do the check on these, I'm expecting the negative 2 to be bad, because that would make negative 8 over here. And if I had negative 8 over here, absolute value of 2x plus 12 equals negative 8 would make no solution. Whereas if I plug in the 6, I'll get 24, and that 24 should have a solution. So if I plug things in, 2 times 6 is going to make 12 plus 12 on the inside. So that 12 I got from doing 6 times the 2. Is equal to 4 times x. So 4 times 6, which is 24. Absolute value of 24 is equal to 24. So that side works. So that means I know 6 is a solution. For the one on the right, If I plug in my -2, I'm going to get 2 times -2 is -4 plus 12. And on the right-hand side, I have 4 times a -2. -4 plus 12 makes a positive 8. And then 4 times -2 is -8. An absolute value of 8 is just 8, which is not equal to -8. That does not work. So since that does not work, then that -2 is going to be an extraneous solution, and we're going to reject it. All right, so extraneous solutions are equations that, or solutions that come out by the process correct, but when I check them back into the original problem, they don't work as solutions. The easiest way I think to identify them is to figure out which one would make that one side negative at the start, and then that'll be a red flag to you that that solution is going to come out as extraneous. Go ahead and try this one. Absolute value of x plus 6 equals 2x. Again, we have x on both sides here, so we're going to have to be careful to check for extraneous solution. All right, so I set it up that green line x plus 6 equaled either positive 2x or negative 2x. Then I'm going to go ahead and solve out each of these pieces kind of separately, moving that x over to the right-hand side so I can get all my x's on one side and my numbers on the other side. In my first equation, it turns out when I did that, I'm just left with 1x equals 6, which is kind of what I wanted. On the second one on the right, negative 2x minus x is going to make negative 3x. So I am going to have to take that extra step to divide by negative 3 here, which is going to give me a negative 2 as my solution. So again, I'm going to have to check them for extraneous solutions, and I should be able to kind of make a guess at which one's going to be bad from the start. Now, 2 times 6 is going to make 12, so I should be fine on this side when I'm equal to a positive, but 2 times negative 2 is going to make negative 4, and that's kind of more of a red flag, right? So I shouldn't be able to have something in absolute value equal to a negative, because I learned yesterday that's no solution. But if I go through and do the check, I have 6 plus 6, going 6 for x plus 6 is equal to 2 times 6. And the absolute value of 12 is equal to 12, so that one works as a solution. With negative 2, I'd have absolute value of negative 2 plus 6, which is the absolute value of 4, equal to 2 times negative 2. So the absolute value of 4 equal to negative 4, which is not true, right? Because absolute value of 4 has to be positive 4, which is not the same thing as negative 4. So that's not true. So that's going to mean that negative 2 is an extraneous solution. Meaning when I go to list my answer, I'm going to say that the answer is 6. I know that ramped up a little bit more, especially with the extraneous solutions, and those were definitely the toughest problems that we had to go over in Chapter 1. But hopefully, for the most part, a lot of these things in Chapter 1 were things you were able to do. I think today probably was a good time for us to learn and kind of realize that we need to be writing this stuff down. So if you're doing this without a notebook and without a sheet of paper to kind of track along with, it's going to be a lot harder to get the questions right in the Ed puzzle. Hopefully you're ready to start the Big Ideas homework now for section 1.4. Good luck on that. You can contact me if you have any questions on this stuff.